Hello and welcome back to the lab. Today on the bench we have something that we're going to have to open. Oh, there's the front, and it's upside down. We have a very old Panasonic, just AM/FM radio. See if we can pull a date code off of this, see when it may have come in, but it needs some TLC to keep going. This one is a solid state unit, so it's going to be younger. Oh, one of the dots came out of the control knob. So it's a solid state unit, so we won't have any tubes inside. When we're still advertising individual transistors, so we have 7 diode, 10 transistor, and it's a model number RE7257. Do have provisions for an external loop. Very tiny screws to get into this unit. I have no idea what kind of construction we're going to find in here. I was asked to take a look at this and service this up and get it going. I know it was plugged in recently, so it is safe to plug in, but we'll still use the isolated supply. We'll give it 2 amps of current, and I don't know if if y'all are going to be able to hear this, but turn it on. So it does receive, but it's fluttering pretty badly. This control was really noisy. But we have a let's see. Doesn't look like we're even trying to receive on AM, so it's not healthy. It's actually worse than I thought. I thought we were going to get away with some cleaning and a few minor repairs, but looks like we're going to have some troubleshooting to do, which is always fun. So let me get the back off and take a look at what we're even looking at, and we will go from there. Okay, to get into this unit, we have some small brass wood screws. Oh wow, we have a mix of chassis and PCB wiring. I was thinking we may run into something like that given its age. Oh boy. We have a transformer. But then it also looks like we have, that wouldn't be a switch mode power supply. Let's see, what do we got? This has got to be the audio amp board, because the speaker's up here. We actually have a tuning capacitor in here, so nothing digital. This is going to be an all analog set. Definitely have some caps that I want to replace. Interesting mix of terminal tie point and PCB. I've got some work to do, but I've also got a service manual I need to look up because this one's probably going to get some alignment. We do have a dial string. We'll try not to mess with that if we can. Nice, great shape though. A little bit of dust for its age, but nothing horrible. Well, we'll just take it one step at a time. Go from there. Okay, some screws all over the bottom of the chassis, and then one right here and one right here. And the chassis comes out as a unit. I do have it unplugged. Let's take a look at the dial face, actually. So That's tuning. Neat dial face. I really don't want to have to, if I can do this without disturbing the dial string, I'll be, oh, here's some, without disturbing the dial string, I'll be good. Here's a couple of transistors. Lots of adjustment points in this radio. Wow. There is quite a bit going on here, and there is some crust in some of these caps. I can see it. From looking at it, I'm just kind of planning my attack on how to get at some of these components. From what I'm seeing, I'm suspecting the oscillator section with the tuning capacitors up here, but I'm also seeing no electrolytic capacitors in there. We have some ceramic discs and coils and everything like that. So tuning's going to be up here. We have a gimmicked capacitor. We have a gimmicked capacitor right here. And let's see, yeah, tunable slugs and a few other things. So not much to do in this section. This is going to be the problematic section down here, is getting at some of these bulk caps. Might be nice if I can unscrew this board, if it'll flip down and I can get some room to work on it. But let's see if that's actually possible. That would be, I have unplugged the radio before we go sticking fingers in it. Well, it's not going to interfere with the dial string, but man, there is not a good way. So this wiring here is for those transistors that are on the back side of the chassis. They're heat sinked to the chassis. I've got a lot of caps in here that I'd like to replace, but if I could get at them from the other side, it'd be easier, but the tuning dial's in the way, and I just don't have a lot of wire. Ugh. Okay, well, that's going to be our biggest challenge. How are we going to get at that? Okay, we have the capacitor board hooked back up, and this is actually the bulk electrolytic cap coming off the transformer. So we have a 2-diode full wave rectification, not full bridge rectifier, but full wave rectification, 2 diodes, 1 cap, and a center tap on the transformer. We have the other power board down here. Now, for those that are watching this, maybe screaming at the TV at the moment that I put in every single one of those capacitors backwards. I did not. However, on these particular caps, come on, focus. The plus side is marked, not the minus side. So keeping that in mind as I was doing this to get them all in there in the correct orientation was kind of entertaining. So what I'm going to do now is I've got the bulbs switched out because this is only a 7-watt radio. It does not need anywhere near 240 watts of current limit, so we have it back on a 60-watt current limit. I'm going to plug it in and turn it on, just let it run for a little bit, make sure the everything's okay with the power supply. Nothing got damaged or overheated with the soldering iron or anything like that. So let me plug it back in. The speaker is still hooked up, so we should hear some noise out of it, and we'll go from there. Okay, we'll turn this on here real quick. No smoke. We are on. We are drawing 3 watts, which is not bad. Well, we already got a healthier radio. It sounds a lot better. I've actually got signal, and it doesn't sound horrible. So we'll just let that cook for a little while and just make sure everything's all right. Oop, turned it off. But I did increase the capacitance quite a bit on some of these capacitors. Our physical size difference, I mean, this is 1,000 microfarads at 10 volts, It's got 1,000 microfarad at, I think, 50 volts in there. So the size difference on some of these caps is extremely large. But I still need to clean the controls. Haven't done that yet. And then I also need to recap this board over here. I have not done that yet either. So making progress and getting closer, but not quite there yet. But the hard part's done. And the lines on the side, all of these wires here, those are for the 2 transistors that are heat sinked to the chassis on the other side. My guess is just where they are and what they're doing in circuit. I'm guessing they're shunt regulators, so they're their actual regulation element for the power supplies. Could be wrong. Haven't looked at the schematic yet, but that's my running assumption at the moment. I am going to have to order a service manual for this. Was not able to pull one up. Sam's has one, so I'm going to get that ordered. That should have the alignment procedure in it, so I can do an alignment on this before I send it back to its owner. And we have the other board finished. So we have the, I believe this is the FM board finished up and should be good to go. So this radio is up for an alignment. We did have, where was that cap that was real bad? We had this capacitor here that the top's domed up, the heat shrink's pulled back. You can tell this one's gotten a little hot. And then if we look at the bottom's starting to get pushed out. So this cap was definitely hot at one point and was bad. So when doing the alignment on this particular radio, they specify using an isolation transformer. And they also want the line voltage at 117 volts. So I am on a dim bulb still, just in case anything goes catastrophically wrong, but I'm on the isolated supply. Got everything warmed up. Equipment that I'm warming up in the lab. I'm warming up the 8657A signal generator. I'm warming up the frequency counter just to double check that the 8657 is on frequency from the rubidium. I've got a scope warmed up just in case I need it, which I don't because this radio uses the peaking method. I got a DMM on just in case, but I'm also warming up the 410B because I'll be using the 410B for this alignment. Oh, I need to fire up the 4162 as well because I will need the FM modulation out of that to modulate the 8657. I've been asked to kind of talk about how I'm applying the test gear to devices under test in previous videos. So we're going to try doing that. Let me know what you guys think in the comments below. And I can definitely go more in depth into what I'm specifically doing with the test gear to get the answers I need or get an alignment done, things like that. Oh, now I know why Paul does these with the audio off. Whoa, listening to that 400 kilohertz tone drive you nuts. So, pointer. A, 1, 2, and 3 are on the side of the oscillator board. I think that's the oscillator board. I need to adjust those for maximum signal. The tuning capacitor is fully meshed, fully open, which means the dial pointer is at the top of the scale. We have the 410B. Here's the vacuum tube for the AC line hooked up across the speaker terminals. We are indicating the 400 hertz tone on the 410B. If I give this a little bit of volume, you can see we'll get some indication. So what I'm going to do now is I'm going to boost the signal a little bit so I can overwhelm the noise, and then we'll tune this for maximum amplitude. I'm going to do this off camera because I don't want to annoy everybody, but I feel it is a little bit off. I have 100 microvolts of signal coming in. We have 100 microvolts of signal coming down, coupling into the ferrite rod antenna. That is properly terminated in 50 ohm. So it's 100 megavolts RMS. That's pretty strong for a signal, but I'm also not directly coupling into the circuit. I have this coil of wire just hanging off the side of the ferrite. So it says just enough to get signal, tune for maximum. So that's what we're going to do right now. Well, I tuned it, but as soon as I started tuning the coils, it detuned. So at least from the start of this alignment is looking very, very healthy as is right now. So there may not be a lot to do for the alignment on this one, but I may not be able to get it much better. So, but we'll go through alignment and figure that out. Okay, so we have to update the function generator, or RF signal generator, to 164, 1.64 megahertz. And still with the capacitor completely open, we need to adjust A4 up top here on the cap for maximum signal. Now we are still modulated at 400 hertz, so please bear with the buzzing. That's going to be about it right there. Now we need to change the tuning a little bit. We need to adjust the RF generator to 1400, 1.4 megahertz. Frequency 1.4 megahertz. And then we actually need to tune to the signal. And then we need to adjust A5, which is the second tuning gang, this capacitor right here. This is a non-inductive tool. So let's find the signal. Yeah. Actually, I'm just checking where it landed in the band. It actually hit right about 1400 kilohertz, so that's good. I'll tune this for max. That cap's pretty, that one's pretty good already. Yeah, it comes off. Yep, that one's all right. Now we want to do the same thing on A6 at 600 kilohertz. We're going to wind this down. There's max. There's the frequency, and then we need to do A6. A6 is this slug right here. The alignment on this is really good. I'm not having to move. I'm not having to move much, so everything is even with having these boards out, replacing all the capacitors. Now we didn't replace any tuning capacitors. Like there's some polystyrenes on here and things like that that are actually helping with the tuning. But just replacing the electrolytics didn't seem to disturb the alignment that much. Obviously, we're going to go through the process, but right now it's looking pretty good. In reading through some of the alignment manuals, procedures, and other things for this particular chassis, and looking around the lab, I am at the moment, not able to do the FM section in this radio. So I spoke with its owner, and it was determined that we should just leave it alone. It is receiving very well on FM, and given that the AM section didn't need any adjustments at all, we're thinking we're just going to run with it as is. A lot of the major concerns that were had, the noise in the controls, the lack of receive, things like that, were actually addressed with the addition of some capacitors. I need to make some protection boxes for my spectrum analyzer before I want to hook it up to this radio. So I did tell its owner's in town, and he's interested in getting it back in the back in his possession. So I did let him know that once I get those protection boxes made, I'd be more than happy to double check the alignment section for him, and he was good with that. So I'll prioritize making those protection boxes and get them going. For those that haven't used spectrum analyzers, spectrum analyzer inputs are very fragile, very easy to blow up, and very expensive to fix. So I just want to take probably more caution than I should, but it's the caution that we're going to take. So at this point, this radio is actually finished. There is one thing that I wanted to point out. Let me get it back in the chassis, get the knobs back on it, and then we will. I'll run it through the bands, and we'll just see how well it receives. Okay, we are back in the case, and everything is on. I don't know if you guys can hear that. That noise is actually being generated by the isolation transformer. If I plug that into a normal power strip not on the isolation supply, everything sounds fine. This receiver is not using an external antenna, so it's actually provisioned to use the 110 line as the FM antenna. So I was thinking that noise may have needed to be tuned out, but I tested it on the normal supply, which we'll do that right now. Just unplug this from the isolation supply, pop it into a power strip on the bench, and it's dead quiet. So if we tune in a station, can't play that too long because the channel will get a music strike, but the so it's receiving very well, sounds really good. The tone is nice, and the radio is performing very well and ready to go back. Like I said, once I get those protection boxes, we can take a look at the FM side, things like that. But also, I do know that this particular radio, come here, Dust, has been a single unit, single owner. It's never left his possession, and it has never been touched with a screwdriver. So it still does have the factory alignment on it. So as of right now, without having the appropriate gear, even in my lab, I'm lacking a little bit of the appropriate gear to get that done. This is the best thing to do for the customer at the moment. So they're aware of that. I'm aware of that. We're both good with where it's at. So that's what we're going to do. So what happened in the lab and why? What's going on with the gear? Well, I have what's called for in this alignment is a scope that has a 60 hertz ramp voltage for the horizontal sweep. None of my tech scopes do that. So I can't use any of the tech scopes that I have to set up the FM alignment. My Rigel generator right here and right here can do the FM modulation, but they can't get the signal quiet enough. Because they're function generators, not RF generators, they don't actually drive the signal at a low enough level. My 8657 doesn't do very well with FM, and I can't put the 450 hertz sweep on the 8657 that the service manual calls for. I can set up the 450 kilohertz sweep centered on 10.7 megahertz on the HP 3565B, which is the device that I will end up using to do the alignment of the FM section finally, but I don't have the protection boxes that I need to protect the input of the spectrum analyzer and the tracking generator, just in case this wants to backfeed some voltage. The tracking generator on that would be protected by a 0.001 microfarad capacitor because you put it through a blocking capacitor. The input, however, would not be. So I want to get some lighter coupling in there if I'm going to do that alignment. So the appropriate tool is at least in my lab with what I have available, is the 3565B. But I need a little bit more tooling before that's useful. So that's where we're at. That's where we're headed. And for right now, this one's ready to go back. So I thank everybody for joining me in the lab and taking a look at this Panasonic solid-state receiver. It is performing much better than it did when it walked in, and pretty close to factory. I mean, it has the factory alignment on it, so with everything being good there, hopefully the owner of this radio will enjoy it for some more time. I'm also going to see, because it'll probably come back, I'm going to see if I can get different knobs or if I can find the black discs. The glue is just failing from being so old. It's nowhere near being glue anymore. So, but I'll have to see what they want to do. That one's not my call because I don't own this box. But thanks again for everybody swinging by. If you're liking the content, hit the subscribe button, the thumbs up, and all the bells. And as always, more is on the way, and I will see everybody in the next video. Bye for now.